What's up, guys? Today is another JoCademy video. Hold on. So, what we will be doing today is a little something different. We will be doing a pre-calculus chapter test on polynomial and rational functions. Okay. So, yeah, this will be about polynomial functions and rational functions. It's a chapter test, so you don't know, it's pretty hard, or is it really? Who knows? Question 1. Determine the root of the given polynomial, given the exact answers, and show all your steps to justify your answers. So we have a function that's equal to x cubed minus 5x squared minus 15x plus 27. Now, how do you solve this? How do you find the roots? Well, p plus or minus p over plus or minus q. And this is q. The roots, or the factors of this, which is 1, is q. And the factors of this is p. So, factors of 27 are 1, 27, 9, and 3. So our possible factors are 1 over 1, negative or positive, 2 over 1, plus or minus 7 over 1, plus or minus 9 over 1, and plus or minus 3 over 1. Now, that's a lot of factors. So, general rule of thumb, use probably number factors 1 through 4. If they don't work, probably just do some. But yeah, I think probably should give up if the first 4 factors don't work. So we're going to set up polynomial division. So we have a 1 right here. That's a minus 5. That's a negative 15. And that's a 27. Now I would probably use 1. If I was guessing, I'd probably use 1 and 3, because 5, 15, 27s are roots of 3 more than any of these others, so I'd probably use 3 or 1. Let's try 1. 1 times 1 is 1. 1 plus minus 5 is negative 4. Negative 4, negative 19, negative 19, 8. That is, this last number needs to be 0. It is not 0. So, yeah, not 1. And most likely not even negative 1, but we'll try anyways. 1, negative 1, minus 6, 6, 9, minus 9. Nope, not 0. So let's try 3. What the hell? Okay. 1, 3, 2, 6, 9, 27. So, probably negative, I'll be honest. So, 1, 3, so this is negative 3. Negative 3 minus 8. Minus 8 is 24. And that's 9 minus 27, 0. So now we have x squared minus 8x plus 9 equal to 0. Wait, no. 0. Oopsie daisies. Okay, so show all your steps to determine the roots. Well, there's one root right here. So x minus 3, x squared minus 8x plus 9 equals 0. We already know 1, so we don't need to, we ignore this. Solve for this. 9 and negative 8. Yeah, I don't know. To get a negative sum, but positive. Negative 3 and 3, 9 and 1. Negative 9 and 1. Does that work? No, it probably might work. Hold on. Okay, I am back. Negative 9 times 1 is negative 9. That is not 9 here. This is unfactorable. So, what I would do, use quadratic formula. X equals minus b plus or minus square root b squared minus 4h. Hold on, this is not the quadratic formula. This is the quadratic formula. Yep, just like that. Yeah, I think that's fine. And it's like 2 squares, so that's crazy. So B is, this is B, A, C. So 9 times 1 times 4 negative. Oh my god. Negative 4. 9 plus 9, 8 squared minus 8 square root this part over 1 times 2. And so 9 times 1 times negative 4 is actually, this is a negative, I guess. That's like fudge. Negative 36 plus 64 minus 8 over 2. This becomes like 28, yeah. So that's like square root 28 plus or minus negative 8 over 2, which really is just normal. Wait. No, it should be plus or minus over here, my bad. Got negative 8, okay. So square root 28, that's 7 and 4, that's 2 squared, so that's 2, and square root 7, plus or minus, minus 8 over 2, cancel out the 2's, so now you get plus or minus 7, 1 plus or minus 7, minus 4, right? No, my bad, it's not. Get rid of this. And so therefore, the answer is negative 4 plus or minus square root 7. And 3, and 3. Yeah. Okay, just check the answers. Yeah, so it's negative 3 and minus plus or minus 4 and whatever. I think, right? Yeah, I'm about right. This seems about right. So, next problem. I can't. Okay, I gotta delete all this. Hold on. Ooh, chocolate balls. Okay, number 2. We got write an equation for 5th degree polynomial function in factor form. Oh, shot. In factored form? Oopsies. Okay, so the problem is saying write a 5th degree polynomial function with these roots. 3x equals 7 plus 2i and x minus 5. So that means it has to be the reverse of that. Also, this is double root. And so here's x plus 5, x minus 7 plus 2i. But if you count the degrees, 2, 3, 4, there's a missing one, which you have to get the conjugate of this, of the irrational number, imaginary number. So, yeah, just like that. And so, let's do this first. So this would be x minus 7 minus 2i. And this would be x minus 7 plus 2i. And then this would be, yeah, that's fine. So that's x squared, x times 7 minus 7x plus 2ix. And then minus 7x plus 49 and minus 14i minus 2ix minus 14, wait, plus, that's plus 14i, and then that's minus 4i squared, which would be plus 4, because I squared is negative 1, that's that. Okay, so let's cancel out these. add these, add this one, cancel this one, so that leaves, okay, hold on. That leaves x squared minus 14x plus 53. And on the other side, we have x squared minus 6x plus 9 times x plus 5. So x plus 5. And so what we're doing is x cubed minus 6x squared plus 9x, and that's 5x squared minus 30x plus 45, and then this is minus x squared. Okay. And then this is minus 21x plus 45. Oh, let's see. Hold on. What the flip? Let's see, 5x squared minus 30 plus 45. Yikes, that's okay, yeah, I think it's right, yeah. And then we multiply these two. Okay, so that'd be okay, x to the 5th minus x to the 4th minus 21x to the 3 plus 45 to the 2nd x, and then minus 14x to the 4 plus 14x to the 3rd, 21 times 14. Let's get the calculations for that. That's around 294. 294x squared plus 45 times negative. Let me do in my head. Around 630. Yeah, that's around 630. 630x 53x cubed minus 53x squared. Let me do this one in my head again. 1001. I think it is right. I think it's about right. Wait, is it right? It could be, could not be. 45 times 53. 2,385. Now, the test says to only practically just get, really just get this part, or even this part, and you're done. But, I don't want to keep going. So x to the 5th minus 15x to the 4th. So that's 67 minus 21 That's 46 x cubed. 294 plus 45 is like 3,000, 3 billion, and then minus 53 is like 1.5 trillion, 286 x squared, and then these two is negative. Okay, so it's like 1743 x plus 2385. I don't know if I'm right or wrong on this one. Let's get a calculator and see. Oh my gosh, I was right. Holy macaronis. I don't even need to do all this, but it's whatever. We ain't even halfway there yet. This might be like a 40-minute video. Okay. Describe the end behaviors of the function of negative x plus 3 squared x minus 4 without graphing. So, right off the bat, degree equals 3, we already know. And there's a negative amplitude, so a equals negative 1. So, based off this behavior, we can visualize a graph to somewhat look like, well, a normal x cubed function will probably look like this, right? But now it's flipped and it's this, so this would be negative x and positive y, and negative y, positive x. So we write the statement as x approaches positive infinity, y approaches infinity negative. Okay, and then as x approaches infinity negative, y approaches infinity positive. So that's A first, that's 3A. So B, determine the zeros and state the multiplicity. So the zeros of this would be negative 3. So we just state negative 3, 0, multiplicity 2, and then we write 4, 0, and mults 1. See? The graph, describe the graph and justify the reason. So the graph will look, I don't really know how to describe it, but it'll go down at 4, 0, straight down to the negatives at 4, 0, and it'll bounce off an x-intercept at negative 3, 0. So basically the answer is what I'm talking about right now. And let's find the y-intercept. So this is 0. Actually no, if y was 0, oh my god. If we plug in 0, 0, 0, so that'd be 3, negative 9, and 4. So that'd just be 36. So and we got like, so I tried 30, 0, 36. So let's go straight down. So rough guess, this is like 36, and this is at 4, this is at 3, negative 3. So it goes straight down. Oops. something like that, straight down, something here, probably make a parabola around here, or something, and then it'll go like that. So, describe however this looks like, I wouldn't know. But the vertex over here would probably be over here. But you know what? I mean, it could be here. Just describe the intercepts basically. You can just say why this looks like how it looks, but yeah. And then D on toi, and is do not scale your axis, but be sure to label important points. Okay, so we're gonna draw the actual graph now. So we're gonna we know there's a bounce. Oh my god. Oh my god. There's a bounce. And there's an intercept. So that's -3, 0. 36, 0. Parabola and straight down. At 4, 0. And so that's the graph. That's how you graph. Okay, so we're on to the next. Oh my god. Number 4 is 2 graphs. So 4 graph and label x, y intercepts and asymptotes. So this should be a little easier. So h of x equal -3 over x minus 7 minus 3. So we have a based off the fact there's an asymptote at x equals 7 because yeah, right here. And then to find the y asymptote, because there is one, because the degree, so there will be a y asymptote if the degree on the top is equal to the degree on the bottom. So degree 1 on here, these 2 degrees, 1 and 1, and so therefore that the degree, so to find a y simple, it is just a over b, where this is a and x is b, its coefficient, and so that would be equal to 3, -3. Okay, and then well, we know, okay, so for x-intercepts we already know it's probably somewhere, so put 0 for, wait, yeah, so 0 equals 3 over x minus 7 minus 3 times x minus 3, so it's minus 3 minus 3x plus 9 equals 0, and so -6 equals -3x, and x equals 2. So Okay. Wait. What the flip? Hold on. Alright, my bad. So, this is a 7, by the way. I thought it was a 3. So, that is minus 3x plus 21. So, that's negative 18 equals negative 3x. And so, x equals 6. So, 6, 0. And for y-intercept, put in 0. So, that's negative 3 over negative 7, so that's cancelled. And then minus 3, so that's 21 over 7 minus 3 over 7, yeah. And so that's negative 18 over 7. So it's 0, negative 18 over 7. And graph that. We graphing that. Okay, and then asympho at 7 and negative 3, so 1, negative 2, negative 3. Please gotta make it to 40-minute mark. Asympho, and then asympho at 7. And then mark that intercepts over here and over here. Wait, no. Negative, so that's like 2.5-ish, like right here. So we just draw a curve like that. And make sure it edges the asympho. It gotta be edging. And the asympho, the other one is like right here. Probably just make it edge like that. I don't know. There you go. And for B, we got 4x minus 4 for x plus 2 equals g of x. So take away the 4, so it's 4x minus 1 minus x plus 2. Alright. And then hold on. Okay, and then yeah, I think that, and since this is 1 and this is 1, and so a over b equals 4, and so therefore x asympho is at negative 2, y is at 4, and then x-intercept 0, 0, so that's negative 4 over 2, so that's negative 2. And for y-intercept, we just multiply, and then x is just 1. Yep. Now we can graph. Okay. It's like the straightest line I've ever seen. And then so let's draw asymptotes at negative 2. So it'll be like and then we got 4, so 1, 2, 3, 4. Boom, 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 boom. No. Okay, and then so it's 1. So let's draw the x-intercept. So there's an intercept right here, and then there's one right here. So it go like this way. So probably like this, and probably like this. Probably. Hold on. So they're gonna connect. Like that. Okay, I checked on Desmos. The concavity of this line it extends farther, a lot farther. So like it just you know, it just, yeah, like that, and probably like that. Yeah, it's from like 4 to ish. It's kind of like that, but you know, whatever. Okay, anyways. On to the last problem. Number 5. It says state the coordinates of any holes and the equation of any asymptote for the graph. So we got 2x squared plus 3x minus 2 over x squared minus 4 equals f of x. We can instantly change this into x minus, oops, okay, and for 2x, so that's negative 4 over 3, and so that's like 4 and 1, negative 1, and so 2x squared plus 4x plus minus x minus 2, and so take out 2x, so it's x plus 2, and this one is minus x plus 2, and it's 2x minus 1 and x plus 2, and that cancels this out, so that means there's 2x minus 1 over x minus 2, and since these cancel, x plus 2 cancel out, the whole is at minus 2, 0, or no, it's minus 2, and plug in minus 2 back into the equation, so that's minus 4 minus 1, negative 5 over negative 4, so 5 over 4. Okay, asymptote at asymptote at x equals 2, and y-intercept, since it's 1, 1, 1, 1, and 2 over 1, y equals 2, right? And then that's all. Sketch a graph for the equation. So now here is the graph. Oh gosh, golly gosh, Oopsies. Okay, that's fine. So, I made an XY table, and I graphed it. And here are the x-intercepts. We'll get the x-intercepts. So, x-intercept, 2x minus 1, so that's like 1/2, 0, right? And then, let me think. And then the 0, that's that's 1/2. And it's like, they're like opposite, right? And I found out in the XY table, a lot of it is flipped. So if I put in 1, it'd be -1. If I put -1, it'd be 1. If I put in 3, it'd come out 5. If I put out 5, it'd come out 3. So basically they're flipped. Like, what the flip? So anyways, so this is 1, -1, -2, whatever. And this is 4, 5, 6. So we put a 0. No. 1/2 and 1/2. So 1/2 right here. So it's going like this way. Oops. It's going this way. Put a hole at -2. And then probably want to write that down here. And on the other side, 5, 3, 3, 5. So this is 3, 4, 5. So 3, 5, 5, 3. So it's probably like this and this. And there you go. 42 minutes on the clock. JoCademy going over time. That's crazy.